Assalamualaikum and hi. We are from Group 1. My name is Shazun Zaruni and my team member is Fariha Adriana, Sharul Iman and Irene Petrus. We are going to cover these three topics, that is electron spin, the Pauling exclusion principle, and many electrons, atom and periodic table lah for this video. About the electron spin, what is the electron spin actually? Electron spin, there is a two direction, there is spin up and spin down. The spin up and spin down direction are corresponding to the spinning in the positive z and negative z direction. These spin are the particle that have spin as equal to half for electron. In the quantum theory, the electron is thrown off as the minute magnetic bar and its spin point to the north pole of the minute bar. If two proximate electrons have a similar spin direction, the magnetic field formed by them strengthen each other and therefore a strong magnetic field is gained. But if the proximate electron have an opposite spin direction, which is from the right and from left, the magnetic field formed by them is cancel each other and no magnetic field is existent. I will pass the example question to the next presenter, which is Adriana.
So, for the first equation, we have to derive how we get the equation Fz equals to mu s cos theta dV over dz. So first of all, we have to know the potential energy of an electron in a magnetic field is referred to this figure 12.4. This one, as you can see how the Seeger transition without an external magnetic field and how 5 transition with an applied external magnetic field. We have to know that based on that figure. So EB equals to negative mu s times B equals to mu sx dx for x component minus mu sy by for y component and negative mu sz bz for z component. We have to know that there are 3 components in this magnetic field. So for the field of figure 13.1, this one, as you can see there are 3 components x, y and z. Okay, this one is the figure. So based on that figure, by equals to 0 and bx and bz depend only on x and z. Therefore, fx equals to dEb over dx equals to mu sx dbx over dx plus mu sz dbz over dx. For Fy, we have to know that just now we already said that By equals to 0, therefore Fy equals to 0. And then Fz is negative dEb over dz equals to mu sx dbx over dz plus mu sz dbz over dz. So, but along the beam axis, dbz over dx equals to 0 because it's symmetry, and dbx over dz equals to 0 when it refers to antisymmetry. Also, dbx over dx will be very small. Consequently, fx equals to 0, Fy equals to 0. Therefore, we do get Fz equals to mu sz dB over dz equals to mu s cos theta dB over dz. Next, for the second equation, 13.2. Determine the maximum separation of spin of hydrogen atom that move a distance of 20 cm with a speed 2 exponent 5 amp per second perpendicular to a magnetic field whose gradient is 2 times 10 to the power of 2 T over m. Neglect the magnetic moment of the proton. This one we have to refer chapter 17. So, in the ground state, hydrogen atoms have zero orbital angular momentum. From problem 13.1, the force on hydrogen atom is Fz equals to mu Sz dB over dz. Therefore, by 13.3 and 13.4 with Gx equals to 2, therefore mu Z equals to negative E over M times M H bar. So that we do get the magnitude of Fz equals to EH bar over M times mz dB over dz equals to, so we simplify it into EH bar time over 2m times dB over dz, and we just simply insert all the value, which is 9.27 at exponent negative 24 j over t, and 2 times 10 exponent 2 exponent 2 t over m, so we do get 1.85 times 10 to the power of negative 21 n. Using the constant acceleration formula, delta z equals to 1 over 2 a z t squared, and delta y equals to vt. So we obtain that delta z equals to 1 over 2 a z t squared, and we simplify all the equation. So 1 over 2 fz over mh times delta y over t squared, delta y over r squared. So we do get the mass of hydrogen is 1.67 times exponent negative 27 kg. So delta z equals to 1 over 2. We just simply put all the values here. So we got 5.54 times x times 10 to the power negative 7 meter. Since this is the displacement up or down, so the total separation we have to times 2. So 2 times delta z equals to 1.11 exponent negative 6 meter. So next, for the third equation, we have to determine the energy difference between the electrons that are aligned and anti-aligned with a uniform magnetic field of 0.8 t when a beam of free electron moves perpendicular to the field. So the answer is, from problem 13.1, we have to know that Bx equals to By and equals to 0. So Eb equals to negative B mu C equals to Eb equals to negative B mu Sz equals to negative B times negative E h bar over M times M S. So we get delta Eb equals to B times E h bar over M times delta M S equals to, and we just insert all the values. So we know that B equals to 0.8 t, and then E bar is 2. E h bar over M, we have to know that E times 2 5.79 exponent negative 5 eV over t, and delta ms is 1 over 2 minus 1 over 2 equals to 9.26 times 10 to the power of negative 5 electrovolts. So that's all from me. Thank you.
Okay, so Assalamualaikum warahmatullahi. So my name is Muhammad Shazwan Muhammad Zarani. So I will continue the question for 13.5 lah. So for this question, this question asks us to express L dot S in terms of JLS, right? So first thing first, we have to evaluate lah J dot J. Actually we have two way to solve this question. For the first thing, we can evaluating j dot j is equal to j modulus square. So this is a common equation that we have to know. So whereas j is equal to L plus S, right? So this is the equation also we have to know lah. J modulus square is equal to L plus S, the L plus S, because of kan we see that j is equal to L plus S, kan? So when we have a j square, so L plus S too should be 2 lah. So just solve this one until we got this expression. So another way to solve this question is we have to use this formula. So L dot S is equal to half j squared minus L squared minus S squared. This is the common formula lah. So we just substitute this one and S here. So we just solve this equation. So we got this equation. Alright, so next question, we have 13.6. So this question asks us to calculate a possible value of L dot S for L is equal to 1 and S is equal to half. So from this formula, okay, we got this from the other from 13.5 question. From this, okay, we got this equation, right? So we just have to use this equation back lah. So this one, so for j equal to 3 over 2, we just substitute this one and we get half h squared. So for j is equal to 1 over 2, we got negative h squared lah. So it just illustrate the relative orientation of 3 vector here. So that's all for this question. So next question, 13.7. This question asks us to estimate the strength of the magnetic field produced by electron orbital motion with result in a 2 sodium D line. So we got here 5,889.95A and 5,895.92A. So this transition occur between L is equal to 1 state and L is equal to 0 state. So only L equal to 1 state is split out. The difference in energy between L equal to 1 substance can be obtained from a wavelength different by E equal to hc over lambda lah. Ni common equation lah from de Broglie, kan. So kita kena cari dulu dia punya energy tu, kan. So we just substitute the value here. So we got this one lah in EV, kan. So this energy can be related to the magnetic field produced by electrons orbital motion. So kita kena masukkan, kan dia cakap dia nak B kan kat sini, kan, estimate strength of magnetic field, kan. So kita kena cari B ni lah. So kita guna je equation ni. So just masukkan nilai kat sini. So tu, lepas tu kita dapatlah B dia berapa. Next question, 13.8. So calculate the value of K using information given problem yang sebelah tadi. And S is equal to half. So for S is equal to half, the 2L is equal to 1, and state J is 3 over 2 and J is 1 over 2, and from a previous question lah. So we just use this formula. L dot S is equal to half h squared, dengan when J is half, Ls is negative h negative h squared from this equation. Okay. So when we got this one, we just have to use this formula, that is E equal to K times with L dot S minus with K when S is lower. So this is the upper and this is a lower. So we just substitute the formula, the value over here. So when we solve this question, we got K is equal to 3.28 times with 10 power 27. So that's all from me. So thank you.
Okay, the first question is calculate the first three energy level for non-interacting electron in one-dimensional infinite square of wavelength 6A. 6A ni adalah dia punya area di mana kita akan gunakan formula En equal to n square h square over 8ma square. Di mana n ni adalah sama dengan energy level. Kalau energy level dia equal to 1, so n equal to 1. Kalau energy level dia equal to 2, so n equal to 2. Di sini kita ada first three energy level, maksudnya kita ada n equal to 1, equal to 2, and also equal to 3. Dan kita akan masukkan dalam semua formula ni, semua amount of the values. 12.4 times exponent 3 ni kita dapat adalah h adalah Planck constant, c adalah speed of light, lepas tu kita akan convertkan kepada EV. Dan kita akan dapat 12.4 exponent 3. Di mana mc pun sama, m adalah mass of the electron, c is the speed of light. Dan kita akan dapat jawapan for E1 sama dengan 1.04, E1 sama dengan 1.04, dan E2 sama dengan 4.16, dan E3 equal to 39.36 eV. Okay, for the next question is what are the energies of the photon that will be emitted when the 4-electron system return to its ground state? Maksudnya, apabila energy level yang tadi itu dia turun ke bawah, di mana from the highest energy level to the lowest energy level, di sini the energy of the emitted photon will be equal to the energy different. Maksudnya, energy untuk E2 tolak E1 sama dengan EA. Di sini kita akan dapat 3.12 eV. Formula untuk kira ni sama dengan formula yang previous question tadi. Kita akan masukkan sahaja value dan kita akan dapat energy untuk seluruh transition, di mana EA sama dengan 3.12 eV, EB sama dengan 5.20 eV, EE sama dengan 8.32 eV. Okay, for the next question adalah consider three non-interacting particles in their ground state in a one-dimensional infinite square well. What happen when a magnetic field is turned on which interact with the spin? Maksudnya di sini kita akan tengok the electron bila ada magnetic field dan bila tak ada magnetic field, apa akan terjadi. Di sini kita akan menggunakan formula di mana terdapat magnetic field where E initial sama dengan E and minus my mu S darab dengan B. B is the magnetic field. Di mana setiap pergerakan ni, contoh di sini V dot magnetic field, kita akan dapat elektron tu dia bergerak ke atas ataupun daripada the highest energy level dia akan turun ke bawah. Di mana bila ada magnetic field, every phase yang dia lalui itu dia akan turun ke bawah untuk yang paling tinggi, dan yang contoh n equal to 1, the energy level dia akan naik ke atas. Di sini kita tahu ada empat perkara penting yang mana N, L, M, S, di mana every electron dia akan spin sama ada dia adalah positive half ataupun negative half. From here we can see that with the spin of the negative half particle occupying the lower sublevel and a spin of the positive half particle occupying the upper sublevel, di mana yang positive half tadi dia akan menguasai bahagian atas energy level, dan bila kita nampak negative half kita tahu bahawa dia sedang turun ke bawah dan dia sedang menguasai energy level yang di bawah. Okay, so the next question is in one-dimensional infinite square, where length of A, there are 5 times exponent 9 electron per meter. If all the lowest energy level are filled, determine the energy of the most energetic electron. Maksudnya di sini kita kena cari di mana ada 2 elektron pada setiap energy level. Di sini kita akan gunakan yang formula N over A. N over A ni telah diterangkan pada topik sebelum ni, di mana N over A sama dengan 2N over A, kita akan dapat 5 eksponen 9, di mana kita akan gunakan formula ini untuk dapatkan berapa dia punya per unit length, maksudnya per unit area. Sama juga kita akan gunakan formula En equal to N square H square over 8Ma square, di mana kita akan masukkan semua jawapan yang kita dapat dan kita akan dapat 2.35 eV. Soalan terakhir adalah if a nucleus is approximated by one-dimensional square well, there will be about 1 neutron per 10 exponent negative 15 meter. In this approximation, determine the energy of the most energetic neutron. The neutron mass is 93 MeV. Ini sama dengan problem 14.4. Dia punya formula pun sama aja, lebih kurang aja. Di mana kita akan dapat, tapi di sini yang berbezanya dia telah berikan berapa per unit length diberikan, iaitu 10 power of 15. Kita akan gunakan ini dan convert kepada per unit area. Kita akan dapat 0.5 times by exponent 5 per area. Kemudian kita akan masukkan ke dalam formula En equal to N over A square has C square over 8NC square. Dan kita akan dapat jawapan kita adalah 51.2 MeV.
Assalamualaikum warahmatullahi wabarakatuh. Sekarang kita akan masuk chapter 15 iaitu Many Electroatoms and the Periodic Table. Okay, jadi apa yang kita perlu tahu dalam chapter ni? Chapter ni terdapat dua prinsipal yang penting iaitu Pauli exclusion principle dengan Abao principle. Okay, Pauli exclusion principle menyatakan no two electron in an atom can have the same four quantum numbers. Bermaksud dia mesti asing-asing. Dia takkan sama arah. Dia takkan dalam satu quantum number ni dia takkan ada sama arah. Dia takkan dua-dua anak panah ke atas, dia takkan dua-dua anak panah ke bawah. Okay, this is what it means. Next is Abao principle. Abao principle, according to the Abao principle, electrons are fit in an orbital in the increasing order of orbital energy level. Bermaksud dia akan mula kita susun macam ni, 1s, 2s, 2p, 3s, 3p, 3d. Jadi dia akan turun secara anak panah macam ni. Maksud 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s. Dia macam tu. Dia takkan 1s, 2s, 2p, 3s, 3p, 3d. Dia takkan macam tu. Orbital having the lowest value of n plus l is filled first. In the case where two orbitals have the same n plus l value, the orbital with the lowest n will be filled first by electron. Nombor 2 ni yang bermaksud, contoh 1s dengan 2s, dia punya n tambah l sama. Jadi kita tengok nilai n dia. Nilai n dia adalah 1 dengan 2. Yang mana rendah dulu, yang tu yang akan ke depan. Okay, kita pergi ke soalan. Okay, first question is, assuming a lithium atom to be hydrogenalite, determine the ionization energy for the 2s electron. Explain qualitatively the difference from the experimental value of 5.39 electron volt. Okay, jawapan dia. If the two inner electrons were neglected, the valence electron will be in the n equal to 2 Bohr orbit with z equal to 3. So, this is the formula we use. The ionization energy is 30.6 electron volt. On the other hand, if we consider that the two inner electrons completely shield the lithium nucleus, so the outer electron only sees Z equal to 1, then we submit the value we got to this E2, and the ionization energy is 3.4 electron volt. The actual answer is 5.39 electron volt lies between these two values. This shows that the valence electron penetrates the helium core and thus sees some but not all of the nuclear charge. The inner electrons partially shield the valence electron from the nuclear charge. Okay, next question. Question 15.9. The measured ionization energy of helium is Em equal to 24.6 electron volt. Suppose that the interaction energy between the two electrons of an helium atom is taken to be the difference between their common binding energy. Assuming each move independently in Bohr orbit and the measured ionization energy, determine this interaction energy. According to Bohr's theory, the ground state energy of an electron in the field of a nucleus of charge Ze is E1 equals to negative Z the power of 2. So we include the value of energy. For He, Z is 2, so that if each electron is treated as being completely independent of the other electron, its binding energy by the Bohr theory would be. Jadi kita yang ini kita masukkan ke dalam formula ini. And the interaction energy would be 29.72 electron volt. The interaction energy is positive because the force between the two electrons is repulsive. Okay, next. Calculate the average separation of the electron in problem 15.9. If it is assumed the interaction energy E1 equal to 29.72 arise from the column force between the two electrons, the average separation D is found from. Okay, first, bila dia cakap the average separation D is found from, D kita kena ingat, kita kena guna formula ini. 29.72 tu kita ambil daripada jawapan tadi, dan kita masukkan nilai yang kita dapat lah. Kita hanya bawa D ke tepi, dan nilai K kita ada, nilai E kita dah dapat tadi. Jadi kita akan dapat D equals to 0.484 ampere. Let's see. Okay, next equation. Give the electron configuration for the halogen with one electron less than the noble gas Xe. So, bila dicakap electron configuration, kita kena ingat dua prinsipal yang kita awal-awal tadi, iaitu Pauli exclusion dengan Aufbau. So, Aufbau menyatakan kita kena susun ikut 1s, 2s, 2p, 3s, 3p, dan Pauli mengatakan tidak ada elektron yang akan ada sama dalam satu state. Question 15.31. What transition element has the electron configuration 1s, 2s, 2p, 3s, 3p, 3d, 4s? So kita kena kira semua ni akan dapat 26. So bila kita tengok dalam table, apa yang ada 26 elektron, iaitu barium. Next question. Give in spectral notation the possible state of an atom which has a closed core plus 1d electron. So the answer is 2d 5/2 and 2d 3/2. Yang ni kita ingat, yang ni adalah Pauli. Question 50.33. List the possible state Ml, Ms of two equivalent Nd electrons. Maksudnya dia nak two possible state Ml, Ms of two equivalent Nd. The 45 allowable combination of quantum numbers 10 things taken two at a time yields 33 states. So inilah jawapan dia. Next question. For a field of 2p, calculate the Zeeman energy splitting of the 2p/12 and 2s1/2 states in Na natrium. So the answer is plus minus 3.86 multiplied by 0 to the power of negative 5 electron volt, or plus minus 11.58 multiplied by 0 the power of negative 5 electron volt. Sorry. Okay. Next question. The 2p1/2 transition in NHR has a wavelength of 5895.98 ampere. Calculate the wavelength changes in a 2T magnetic field. So kalau wavelength, we use a certain formula to get this answer. Okay. Next question is, assuming the LS interaction to be much larger than the interaction with an external magnetic field, calculate the anomalous Zeeman splitting of the D, and this D states in hydrogen in field of 0.05T. Okay, the answer is untuk yang ni kita akan dapat plus minus 3.47 multiplied by 10 to the power of negative 6 electron volt, and plus minus 1.16 multiplied by 10 the power of negative 6 electron volt. Manakala untuk this, untuk 2D 5/2, kita akan dapat plus minus 8.68 multiplied by 10 the power of negative 6 electron volt and plus minus 5.21 multiplied by 10 the power of negative 6 electron volt and plus minus 1.74 multiplied by 10 to the power of negative 6 electron volt. So that's it from me. Itu saja daripada saya. Terima kasih. Assalamualaikum.